My name is Darshan Patel, and this is a video walkthrough of the Physics Lab 1 constant velocity. So a brief overview of this lab is that first we were tasked to observe the motion of some object that is moving at the same speed without changing direction. Then we had to capture a video of the motion and analyze the video using Tracker to extract the object's positions and corresponding times. Some lab specifications are that the motion of the object should be one-dimensional, so it should move in a line, and the video should capture the motion across the screen, so the object shouldn't be coming towards you or going away from you from the point of view of the camera. Also, we cannot move the camera while capturing the motion. For using Tracker, so in Tracker I used the calibration stick to set the scale of the scene, so I made sure that there was something in my video for me to know the size. For example, putting a ruler or meter stick somewhere in front and center would help me accomplish this. It does not have to be a ruler or meter stick, but any object that has known dimensions can work. So this is the Tracker data. You could see like the object in the frame of the video. Like it was a steady like frame, so you could see like the object through one camera angle. The camera isn't really moving, only the object is, and also you can see like the red like squares on the screen, which kind of shows like the motion of the object. And you can also see like the linear graph on the top right corner of the image, which shows like the linear relationship between like the motion of the object. And interpreting the Tracker values, you can see that the Tracker's values start in the negative direction, which is due to the fact that I started tracking the object's motion a bit left of the origin at first, and so that just makes the object start in the negative x direction. We used GlowScript to make a computational model that accurately describes our observations based on the physics principles of Newton's second law or the momentum principle. And changing values in GlowScript, there was code that we already wrote from Lab 0, and that code applied to this lab too. So for this lab, we had different values for the delta t, initial velocity, initial position, and time elapsed. So we used those values instead of the original Lab 0 values, which can be seen in this image right here, where we changed the values for initial position, velocity, time elapsed, and the delta t. And this code overall shows the iterations of position and velocity over each delta t. And using Excel to compare data, so after obtaining the data from both the GlowScript and the Tracker, we used Excel to plot a observed position versus time plot. And so this is the plot right here. You can see at first like the graph or like the trend follows in the negative y direction. So like that shows that at first the object's like motion, like it was to the left of the origin a bit when it started tracking it, which is just due to human error. But overall you can see the trend is linear, which shows a constant velocity over time. And some of the lab questions answered are, so if the x-axis was flipped, all the x values like position, velocity, acceleration, and force components would also change sign, but the magnitudes and physical behavior would be the same. And it's not really possible to determine how many forces are acting on the object because there can be any number of forces present as long as their vector sum is equal to 0, like gravity, friction, and air resistance. That's all for this lab. Thank you.